nanohub.org.
Online simulation and more for nanotechnology.
All right. Well, thank you all for sticking around, and thank you to Nadia and to David for inviting me to come talk. This will be a little bit different. I was trained as an engineer. I still think like an engineer, but I'm not really an engineer. And my stuff, sometimes I have a hard time finding a home when I try to publish it because I approach things from a number of different directions. So my talk will actually be in two parts, and I know I only have 15 minutes, so it'll be two very quick parts. But I've been involved recently in two different NSF grants. One is a CRISP grant in collaboration with the University of Oklahoma. Cash Barker is on that grant that Adam mentioned earlier. And with Penn State, with some folks in the information sciences there. And then the second grant I'm going to talk about just for the last 5 minutes, we just recently received an NRT, which is the old IGERT. And we have an interdisciplinary program in disaster resilience and risk management that we're really excited about. And hopefully our students will be doing some really great things over the next couple of years. My perspective, and you'll see this as I go through the project, but the approach that I take, or the perspective that I have on resilience, is I look at operational resilience. And so supply chain resilience is kind of where I've made my home because now I'm in a business school. But I tend to think of it operationally. So in the moment, as things change, what can we do to prevent or to recover or to adapt, et cetera. So it's very much more on the short term, although a lot of my research is really thinking about what can we do to mitigate or prevent in the first place so we don't have to worry so much about the short term, or so we have things in place to be able to deal with that. And so it's a little bit of a different perspective, I think, than a lot of other folks have talked about. And I've sort of been puzzling through in my head how to fit myself in terms of what I say, so that it kind of bridges the gap a little bit. So we've seen this definition of resilience, so the National Research Council, National Academies. This is the one that I tend to use. Also, I like the notion of both preparing for and responding to. And then in my mind, I always have to ask myself these questions, all right, in order for me to measure it. And that's really what I'm interested in, is measuring resilience. And resilience means a lot of different things, and it's very contextual, and it depends on what's resilient. It depends on what it's being resilient to. Being resilient to a flood is very different than being resilient to an earthquake. It's also really important to talk about in what way. Things are very multidimensional, and that really fascinates me to try to figure out if a building is resilient, parts of that building are going to stand up probably pretty well, but other parts are going to suffer, and so you've got the weaknesses. Well, you can expand that to a community. There's vulnerabilities, different kinds of vulnerabilities in the physical infrastructure and the social infrastructure. Can we get a handle on what's resilient, in what way is it resilient, how is it resilient, and for whom is it resilient? We've talked about that a couple of different times. So it's not just necessarily about the physical. It's about how that impacts the community, the stakeholders, the decision makers, the designers, the politicians. And so when we define resilience, you really your definition might change, or the way in which you measure it might change, depending on the perspective that you take and depending on who you're talking about is going to suffer from the impacts of the natural disaster or hazard or disruption that occurs. Okay, I do tend to take a natural disaster approach, and so my conversation is going to be colored by that. So I tend to think in terms of earthquakes and hurricanes and outside forces coming in and disrupting the normal way in which our society or some particular system is actually progressing. So since it's a vision talk, I wanted to kind of bring together the vision of what some of the challenges are. Obviously, it's not a comprehensive list, and I sort of cheated because I was able to take some of the things that people had said over the past couple of days and put them through my lens of how I understand them. I very vaguely split these into these three parts. As I said, much of my research really is focused on characterizing and measuring multidimensional resilience, and very often at this point, as I'm trying to understand how I can do that measurement, I've kind of started with visualization. And so the project I'll look at is really as much visualization as it is measurement, but they kind of go hand in hand. And in particular, when you start talking about communication with the stakeholder or communication between different disciplines to try to explain how what you're thinking is different but yet the same as what the other person is thinking, using a visual approach and doing a lot of hand waving tends to kind of help to understand that we are speaking the same language. Availability and existence of good data is something we've talked about quite a lot, and sometimes the comment was made in the breakout session yesterday that sometimes it's a case that a business or a government has the data and won't share it. Sometimes it's a case that the data is simply not there, all right, or part of the data is there. One of the things that I do is humanitarian supply chains, and I just did a project with the Red Cross in Colorado and Wyoming, and we were looking at pre-positioning supplies so that they can open up disaster shelters. All right, well, the data I really wanted was, well, how many people were in each shelter on any given day so we could kind of see the progression over time of their utilization of the resources. And then maybe a quarter of the shelters had actually kept track of that information. There's a national shelter system database that should have all that data in there. And they're simply too busy to take the time to write it down. And so the data doesn't exist. It's not that they don't want to collect it, but it's simply not there. And so from an operational standpoint in particular, from my perspective, that's a real issue. I had the opportunity to spend some time in Karlsruhe, Germany in 2015, at CDIM, which is a disaster research center there that's based in geosciences or geotechnical engineering. One of the things that they do, which is pretty cool, is they do something called forensic disaster analysis. Not terribly widely known, but the basic idea is when something occurs, like the earthquake in Nepal, they send a team of folks to the location to interview people, to look at local news reports, to gather all this data about what happened with the event, what were the impacts, what were people's reactions, and so really looking at the social side and the physical side and this ephemeral data that's going to go away if someone doesn't go and capture it. They kind of swoop in and try to gather as much of that as possible, but both locally and remotely, so that they can build this picture of what actually happened, so that we know what the actual consequences were in these different dimensions of how an event like that will impact the society. Okay, so data is obviously a big issue. Communication I just talked about and the different perspectives. Language is something that this is pretty interesting in general. And again, in our breakout session yesterday, there was a lot of talk about models. Okay, well, I built this model to do this. And the engineering part of me tracked it exactly. But the way I think about modeling now is a little bit differently because I deal with a lot of social scientists who build very different kinds of models. And in my group that has gotten this grant to do the NRT program, defining resilience is one thing, but even defining model, we had very different perspectives on what that meant, and in conversation, we would find after about 10 or 15 minutes, we were talking about completely different things, even though we were using exactly the same words. So I think that's one of the challenges, because disasters in particular are problems that we have to deal with in a very interdisciplinary way. And in order to do that, we have to be able to understand what we're saying, and the language is a big, big component of that. It's taken us 5-6 years, literally working together to really understand each other, understand our perspectives, so that we can actually know that we're solving the same problem, or know that we're perceiving the same problem. And then the last part is really sort of my holy grail, what I'm shooting for. I'd love to be able to get a handle on, and again, here the data is an issue, but causality, right? I think to figure out what levers as a manager of a supply chain or as an owner of a critical infrastructure system, what levers can I twist and turn in the beginning or along the way that are going to have the positive impact that I want them to have. Okay? And so to get to that point, we need to measure, well, what are the outcomes going to actually be? And then try to back out, well, what changes can we make? What investments can we make that are going to be most effective? In what ways are they going to be most effective? That's a real challenge to get access to that data and that understanding of what can we actively do and what can we do both beforehand for mitigation, but also for that adaptability along the way. What changes can we actually put into place? Okay, so part one, the CRISP project I've been involved with folks from Oklahoma and Penn State, is a project on resilience analytics. And where this came from, we had submitted a CRISP project the year before that didn't get funded, where we wanted to look at the interdependencies between different infrastructure networks, and we wanted to use sensors at the different levels, okay? So transportation network, utility network, et cetera. Use sensors and try to build up this network level view of how resilient is it in different situations, and do simulations. And Cash Barker uses a lot of input-output modeling kinds of things, and sort of adapting that and trying to come up with a good way of characterizing what was going on. Well, we found out that there weren't, in theory, you could put a sensor in anything, but in reality, there weren't a lot of sensors there for us to gather the data to actually do this analysis. And we didn't want to just simulate everything. We wanted to really use empirical data and to be able to do some calculations. And so what we did the next year we came back, we added someone who did social media kind of stuff. And so we added another layer. We added the social layer, the community layer, as an example of another kind of sensor. And so using social media, using Twitter, using other kinds of social media, could we get these signals from the human population that could give us an indication of what's actually going on in the physical networks that are the other part of the infrastructure that kind of makes up the whole community? Okay, so that was the basic idea. We want to get at measuring the overall resilience, but also the resilience in localized areas, and how does that all build up to give us the whole picture. And so there is this notion of multidimensionality. You've got the social aspects of resilience, you've got the physical aspects of resilience, and just to sort of lead into what it is that I actually did, I tend to think a lot about loss versus recovery time. Okay, so you can measure resilience in different ways. I tend to look at it as the trade-offs between those two things. All right, if you have a lot of loss but very quick recovery, that might measure out as the same amount of resilience. There's a little bit of loss, but it takes you a really long time to recover, depending on how you do it. But there's a very big difference between those two things, operationally as well as the impact that you have on different people. So that's one side. And then the other side is there really is multidimensionality. And the work of Bruno and the Engineering Research Institute from way back when, and the seminal paper on the resilience triangle and defining stuff, introduced at that point technological, organizational, social, and economic resilience, these different dimensions. Those are really meta dimensions. You can kind of dig into social resilience. There's lots of different aspects of that, and physical resilience, et cetera. But that's the other way that I think about the multidimensionality. And the way to approach it, particularly if you are looking at the social aspects, is not everything can be measured continuously, and so you need to start using indicator variables that give you some notion of what's going on in each of these different dimensions. Okay, and so the basic idea that came out of that was, can we use indicators of the social response to a disaster as sensors, in a sense, of how resilient the community is? All right? Rather than using Twitter, which is very messy, and you gotta dig through and you gotta analyze, and there's a lot of junk in there, we discovered, and other people have looked at this too, but New York City has a lot of municipal data open and available through their open data portal. One of the things they have available is 311 data. So 911 data is emergency calls. I need an ambulance, I need a fire truck. 311 data is non-emergency municipal services. Okay, street light is out, or a stop sign fell down, or a tree is blocking my driveway, that sort of thing. Things where you don't need help in the next hour, but you need help within the next week. And so what we did was we looked at this 311 data set, lots and lots of data. Okay, basically we got every single call from 2004 until now up through 2018. That everybody made, and what's beautiful about this is it's very highly structured. You've got the date the call is made, you've got the date that it was resolved, you've got the latitude and longitude, you've got the division that they actually called, so you know what they were calling about, there's a description of it, and so it's this really beautiful social media sort of like data set that gives you this very descriptive analysis, or ability to do a descriptive analysis about what people in the community are seeing, and what they need help with, and how they are responding. Okay, so just an example of the amount of data and what it looks like. And what we did was we looked at New York City, so the boroughs within New York City, and we looked over the span of a couple of years, we looked at these 7 different events and how these events impacted people's behavior, their responses, so that we're not just getting, okay, well, this bridge fell down, et cetera. We're getting, well, people are complaining about these, and it's this particular neighborhood that's complaining about this particular situation or this particular problem. Okay, so these were the 7 events that we looked at, and these were the 5 indicators that we focused on. Okay, in one sense, they're all social because they're provided by the people in the city, but you can sort of think of them as dealing with more physical impacts and dealing with more social impacts. And so the first 3 physical impacts that are impacting transportation and healthcare and commercial facilities. So people complaining about a traffic signal being out, or the pole blew down or something. And then the daily activities and the public safety. So a blocked driveway is really more about quality of life. I can't get to work. All right? I can't go to the grocery store because there's a tree that's down that's blocking my driveway, or an emergency truck is blocking my ability to go about my normal way of life. Damaged trees are actually really interesting because when you look into the data, most of the calls about damaged trees came from the more affluent neighborhoods. Because in New York City, if you have trees, your property value goes way up. And so if your tree is damaged, it makes your house look bad, or it brings your property value down, they want help right away to come and take care of that so that they're not dealing with that issue anymore. Okay, so there's some complexities here, and there's lots of other kinds of calls, and there's some digging in to understand exactly what it means when someone calls about one thing in particular. But you can see that there really is, in a lot of cases, a correlation between the number of calls or complaints and actual disaster events that occurred. And so what we wanted to do is look at the resilience of the community as a whole based on this behavior that has been gathered in this big data set. This is how I think about resilience. All right? I think of it as a process, but I also think of it as an outcome because I sort of look at what happened in the past. And so to what extent was there loss and recovery? And built into that is the different characteristics that would lead to the different types of behaviors. And I'm really fascinated by the different parts of this curve. So you've got the amount of loss initially and then the total loss. You've got the length of time it takes to get to that point and the length of time it takes to recover. Different investments that you make in improving resilience might have different effects on different parts of how that behavior actually evolves over time. It's a pretty simple thing. I've gotten a lot of mileage out of it. I think it's really interesting because you can kind of dig into not just was it resilient or not, but what are the different ways in which it exhibited itself as you're looking at that process over time. Basically just a time series curve, all right? You've got the impulse from the outside and then you've got the response, and we can analyze how that response comes into play. Okay, simple math, but it turns out that the equation there at the bottom right is the equation of a hyperbola. All right, and so what you can do with that is that you can do this. All right, so these are the predicted resilience curves. Each one of those lines is a given level of resilience where you can look at the trade-offs between the average loss and the recovery time. And depending on where you are within that context, it gives you a better understanding of, okay, in what way did this system actually respond to a particular disruptive event. Okay? And so it's from top down, it's this two-dimensional surface, but it's really the three-dimensional surface, and we can do some kind of interesting things in terms of the math with plotting the different values. What I think is probably most significant, again, it's sort of a visualization thing, but what is pretty significant about it is you can plot multiple observations at the same time, so you can make it probabilistic. You can measure what happened in a particular instance, but then you can simulate that and come up with what might have happened if we adjust these things. And you can plot everything at the same time, and that's kind of where I'm headed in terms of what this project generated. Okay, so service call data, here's an example of one. We went and took the last couple of years of data and did error bounds and then used just the part by which it exceeded what we would have expected to see. Basically, the deviation from normal, we treat it as if it was a loss. So we're looking at the relative amount of loss compared to what it could have been. And we were able to take that and come up with some overall results for New York City in a couple of different ways. And so this is one of the sets of results. I don't know if it's big enough to see, but damaged tree is the one that kind of sticks out. All right. So what this tells us is that the recovery time was a lot longer for damaged tree, but the length of time, the average amount of loss, the number of times that people would call was actually less. It was more of a persistent, hey, we got a problem, come take care of it. Well, obviously it wasn't as much of an issue as some of the other things to the city to actually come in and deal with that. So that's one piece, is that you really can differentiate between these different dimensions. So where these came from was we took the 7 different disaster events and we plotted the point for each of those. And then one of the other outstanding issues with resilience that Professor Rose mentioned is this notion of weighting and how do you appropriately weight things. What this gives you the opportunity to do is to play around with the decision maker and adjust their weights and see how that impacts the general understanding of how resilient a particular system is. And so these particular blobs that we've got, we took the 7 events and basically Assumed initially that all of those events were equally important, so equally weighted, and got a center point, and then we kind of varied it by 50% to get the cloud of points that shows you, all right, if there's a differing amounts of importance of these different events, then this is what you would expect to see. You can do it this way. You can also do the overall resilience of a particular event like Hurricane Sandy and plot the different dimensions and then look at the combined measure of resilience, not just as a simple combination of those weights, but you can adjust the weights because different aspects might be more important to different people than other aspects, and this gives you the flexibility to kind of play around with that. Okay, we can do statistics, we can do optimizations. It allows us to go a bit further in terms of a variety of different things. So that's the first part. That work has just been published in Socioeconomic Planning Sciences. It's available on the web, but I don't think it's officially made it into an issue yet. But I'm happy to answer any questions or talk a little bit more. This is the second part, really briefly, of my presentation. So it's a disaster resilience and risk management raised to the power of Virginia Tech. All right, so this is our logo for our program. Like I said, it's a NRT-funded program where we just started our first cohort of students this past fall. Our objective is to create a diverse interdisciplinary community. So sort of standard objective stuff, except that we're really focused on stakeholder-focused decision-making, and we're focused on taking a quantitative approach. And one of the sort of central pieces of what we're going to do with our students is have stakeholder workshops where we do foresight planning scenarios. We're working with some folks that have done that for the U.S. military and the government, and get them to understand how different people think about these problems and what can we do to mitigate in advance. And we've got students from the four departments that are really core to this program are business information technology or operations management in the business school, and I've got two students in there. We've got several civil engineers. We have geoscientists who study tsunamis. We've got several PhD students that are looking at the physical aspects of disasters, and then we've got a number of urban affairs and planning folks that are looking much more at the social side of things. Okay, and the point is to have the engineers understand the social side and the social scientists understand the engineering side and appreciate and speak the same language. It is a PhD program. What's significant about it is it's not an actual degree program, so we haven't established a separate department or a separate degree, and so this is kind of novel. If you enter this program as a PhD student, you would enter as a civil engineering PhD student or as a BIT PhD student. And you would take some additional courses and you would participate in Friday seminars every week all year long, and you'd have opportunity for internships, and we got some funding from the National Science Foundation that unfortunately will only fund U.S. citizens. And so we also got some matching funding to a certain extent from Virginia Tech so that we can fund international students as well. Each scholar must have at least one faculty member from a different discipline on their PhD committee, which is kind of a significant thing. And so we're pushing our students to stretch their boundaries, but we're allowing them to still be who they are. All right, so the civil engineers are still earning a degree in civil engineering, but they're getting this additional perspective around the outside. It boils down to an extra 12 credit hours, I think, when you include all of the seminars and everything. And there's a couple of required courses. The core course that they start with is this Principles of Disaster Resilience and Risk Management. And here's where we really get them to start thinking about a common language and understanding how the different disciplines actually interact and how they think about these problems. And then we've got cross-disciplinary objectives in this stakeholder engagement seminar. And we're really trying to build a community of practice around this notion of disaster resilience, and in particular natural hazards and natural disasters is what we're specifically looking at. And so to revisit those challenges through this program, I think the main things probably that we're trying to get at are these. All right, so have our students understand that different people speak different languages, and to give them the capacity to understand the languages that folks in different disciplines are speaking, so that they can have that different perspective, so that we can really come up with transdisciplinary solutions to problems, these really nasty, multidimensional, very complicated problems that take both engineers and social scientists to really understand, because you've got all these different aspects really intertwined in there. And the students so far are really excited about the program. We're now in our second semester, and it is turning out to work really well. We're obviously adjusting stuff as we go, but so far we think that we're hopefully going to be pretty successful with this. All right, thank you.